Whoa. Hey everybody, welcome to Open Space number 100. 100 episodes of me standing here with no plan about what it is that we're going to be talking about. And of course, tonight, like every night, I have no idea. So this is Open Space for Monday, December 21st, 2020. The night of the Great Conjunction, where Jupiter and Saturn come together in the sky. And last night we had cloudy skies here on Vancouver Island, like we always do in the wintertime. And we just had the skies clear up tonight. So I've been able to locate Jupiter. And so as soon as this is over, I'm going to go out and take my telescope and take a look at it. So, and then show the neighborhood. We tried to organize a live stream of it, and it was just terrible weather for every one of the astronomers that we have in our group. So we weren't able to do a live stream of it. So I'm just going to go check it out, and I won't be able to share the view with anybody because it's not a very shareable view through my telescope. But yeah, it's pretty exciting. I'm pretty stoked. All right, let's get into the show. I'd like to make a huge thank you, as I always do, but this time at the beginning, to Nancy Graziano, who has been working really hard behind the scenes to try to organize the live streams for the conjunction, the live streams for the virtual star parties, which I'm sure she had no idea just how difficult it was going to be to bring them back. Everyone was like, oh, you should do the star parties again. I'm like, there is no way I'm taking that on by myself. Nancy, do you want to help me? And she's like, oh, yeah, that sounds great. Yeah, well, here we are. It's hard. So, Nancy, you are the greatest. I really appreciate it. All right, so let's get on to the questions that we have this week. I've got a new monitor set up, so I don't have everything is sort of nice and organized this week. So I can't show you the newsletter, but it was another gigantic week in space news. So I'm happy to talk about whatever topics you're interested in. I have my suspicions about what some of them might be. So once we get into what's been found at Proxima Centauri, once you queue those up, we'll get onto it. But all right, let's get into the questions. So the first one comes from NeuroStream. How do we determine the rotation rate of gas giants? Is Jupiter's 10-hour day based on the movement of the upper cloud deck, or do we have some semblance of a rotating rigid body surface to track? That has been a very difficult thing to measure. And the reality is that, in fact, astronomers still don't perfectly know the rotation rate of, say, Saturn. It's been argued even up to like the last couple of years. We always do articles on Universe Today where it's like the rotation rate of Saturn has finally, we finally know how long a day is on Saturn. And that's because it is a gas giant, and you can roughly know. You look at some big storm on the surface of Saturn or Jupiter, and then you wait until the planet comes around and that storm comes back into view, and then you know that the planet has turned once on its axis. But of course, the storms are moving. Those belts of cloud that are moving around Jupiter and Saturn, that's a lie. They're moving, and so you can't know precisely based on that. And so the way that astronomers have worked out the rotation rate is based on the magnetosphere. So both Jupiter and Saturn are surrounded by this giant magnetic field line, and they can essentially track features in these magnetic fields as they rotate around as the planet turns and come back to the same position. They actually remain quite stable over the lengths of time that are necessary. And so astronomers have used like the Galileo spacecraft and the Cassini were equipped with very sensitive magnetometers designed for this exact job, to be able to measure the magnetic field strength of Jupiter and Saturn. So the magnetic field on Jupiter is about 20 times as powerful, as strong as the one on Earth, and so it's a lot more detectable, while the one that's on Saturn is only about the same strength as the Earth. And so it was trickier to be able to measure it, and so it's only been fairly recently that we finally got to the level of sort of accuracy that you would want to know to say, how long a day is on Saturn or Jupiter. So it's actually pretty tricky, but it's a great question. All right. John Siffel asks if I have any ideas about the mysterious green space blobs. I don't. I haven't really dug into it yet. I think I posted it and handed it off to one of the writers, but I don't think we've covered it yet. So, all right. So, Uncle Bill Druin says, better preemptively address the story about the media spilling the beans on the new WOW signal. Sure. On Saturday, news was starting to break online. I think The Guardian picked it up first, and that was followed by Scientific American, and then all the usual suspects. We're still working on our story right now. That a radio signal was detected coming from Proxima Centauri. And that's exciting. But the kind of radio signal that it was is also very exciting because it is located in a part of the electromagnetic spectrum that is not caused by natural phenomenon that we know of. And I think, we've interviewed a lot of astronomers here on this channel, and they often say that radio SETI is like the best because there are certain frequencies in the radio spectrum that if you detect it, there is no natural way that can be happening. That has to be something that's artificial. And so it's a very exciting signal. It happens to be coming from the closest star system to us. And so that's amazing. And this news was announced by Breakthrough Listen. Now, the first problem is that we don't actually have access to any underlying scientific information. It's been sort of leaking out from person to person, and I'm not sure the exact heritage of the information. The most likely, right? So as we always say, it's never aliens, right? It's not aliens. And so the most likely source of the signal is that it's a reflection from some kind of Earth-based source. So it could be a satellite was passing through the field of view. It could be that a satellite was transmitting something in the field of view, or was bouncing a signal off of something Earth. So that's the most like there is a 99.9% chance that when it finally gets figured out, the answer will be there was an Earth-based signal that bounced off a satellite that was passing right through the field of view just as it was going past Proxima Centauri, and that accounts for the signal. That said, it's a part of the sky where not a lot of satellites are usually seen. And so it's not nothing, but it's almost certainly not aliens. So that's where we stand right now. And obviously, as more information is gathered, as more simulations are done, as more people can figure out what was passing through the field of view at the time, we'll get a better sense of what it actually was. So I almost guarantee that it's not aliens. But what I really like is that it's this very effective test of the system, that Breakthrough Listen detected a potential signal, was able to pick it out from all the other signals that are out there as a very interesting signal to do follow-up research on. And that's great for when we do hear from the aliens. And you might have also heard that there was a detection of an electromagnetic signal coming from, like a radio signal coming from an exoplanet. And the answer for that is far more natural than it is, but very exciting. That essentially, for one of the first times, astronomers have detected the magnetosphere of a planet orbiting around another star. So the star let off some kind of blast of radiation. It reached the planet, it interacted with the planet's magnetosphere, and that emitted a bunch of radio waves, which we know Jupiter does all the time. And so for us to be able to see this radio wave, to know that another planet has a magnetosphere, right? That's one of the potential keys for being able to have a planet that can support life. And so if we see this planet emitting radio waves, then it means that other planets out there have magnetospheres. And we'd always assumed that they did. But the evidence seems pretty overwhelming that if you're going to want to have a planet that's going to have life on it to last for a long period of time, it needs that global magnetosphere to protect it from the space radiation. We have that here on Earth, and we would expect to find that. Now, it's going to be like a massive mega Jupiter, but it sort of, we're narrowing in on this time. We actually did a video about this idea of putting a giant radio telescope on the far side of the moon where it's radio quiet. And if you made a big enough antenna, you could detect Earth-sized planets orbiting around sun-like stars based on the radio emissions coming from their magnetospheres. So it will be an entirely new way to detect exoplanets that would also include telling you that that exoplanet is protected by a magnetosphere, which is such a great idea. All right, let's move on. Do you know roughly what so Yamin Rashid is asking, do you know roughly what the rotation rate is? I forget what the rotation speed is. Jupiter's like 9.5 hours and Saturn is longer, but I don't remember. I don't have that number in my head. But now that I'm watching this video, when I review tomorrow, I will memorize it for next time. Ronald McCoy, you were going to talk about the Chinese language learning software apps that you were last week's Weekly Space Hangout, but didn't finish the thought train. That sounds like me. Yeah, I'm using a piece of software called Chinese Text Analyzer. And it's very simple. What it does is it essentially allows you to read an electronic file word by word in Chinese. And because like, just to make this language even more complicated, in simplified Chinese, they don't break up the words. And so every sentence is just a long string of characters, which could be broken up into multiple words. Some words are just a single character. Other words are two characters side by side. And you have to gain practice to be able to distinguish what's a word and what's a character. And so this lets me go through it. As I learn words, it lets me change them one color, and as I'm words that I don't know, it changes them into a different color. And it forces me, like if I can't mark a word as known unless I am certain. And so at this point, I can read about 80% of any text, any document that I look, which sounds like a lot. Like 80% sounds like a ton, but it is not. It's kind of like imagine you read 4 words and they're like, and it'd be like, as, it, the, and then blurg. And then, and usually the complicated words are the ones that impart the meaning. And so, it's actually quite tricky, and I do have to, spend a lot of time, but it is definitely starting to click now, where I can sit and I can just read a document and get the gist without really struggling. But it's such a long road. I mean, I posted a photo to Twitter that I just wrapped up my second book filled with characters of Hansa. So now I'm up to like, I know about 1,800 letters in Chinese. That's about half of what the average Chinese person knows. Most, if you speak, say, or if you write in simplified Chinese, then you know about 3,500 characters. I think they have a list of about 8,500 that's considered standard. And then in fact, it goes up to like something like 80,000 characters, but they're really obscure at a certain point. So yeah. And so it's like, you have to learn 3,500 letters. So, here in English, we know 26 letters. In simplified Chinese, you need to learn 3,500 letters. And each letter has a different sound. But many of them have the same sound, except a different tone. And so it's so complicated to sort of piece it together bit by bit. But that's what makes it fun. But I can definitely start to feel like I was watching, and then being able to understand what they sound like is a whole other thing. To be able to listen and hear what people are talking about. Which I'm sure people who English isn't their first language and they're listening to me go at high speed have trouble staying caught up with me. But I have gone and specifically signed up for literally every single space-related channel that I can find on Weibo, which is sort of like the Chinese version of Twitter. And then I just force myself to just read each one of them, every tweet, and sort of gain knowledge. So I'm sort of like definitely learning a lot extra Chang'e, you know, words like mission and sample collection and mineral and magnetometer and resolution and things like that. So my vocabulary is very skewed towards space, spaceship, human space flight, taikonaut, things like that. So, but yeah, so I still sort of hold to this. I think probably by the end of, you know, I've been at it for about, say, 6-9 months at this point. I figure by the 2-year mark, I'll be able to mostly read and understand spoken Mandarin Chinese at that point. And then I think I'll be useful. But the thing that's interesting, and you know, as I understand more and more about what's happening sort of currently, it's interesting just to see the perspective of what people talk about in China about spaceflight and how that's different from what's happening here. And I am starting to get, I wouldn't call it scoops exactly, but I am starting to get just, I'm hearing them talk about things that I'm able to put into context, or I'm reading them talk about things that I'm able to put into context and say, oh, that's something that's not been widely reported in Western media about this aspect of the mission. Like they announced the plans for the Chang'e series all the way up to 10, I think. So we're at Chang'e 5 now. And so they laid out what Chang'e 6, Chang'e 7, Chang'e 8, maybe we went up to 8 or 9. And I'd never seen that anywhere else before, ever. And yet there it was sitting. There was a graphic that showed them and all of the bullet points of all of their the features and what their goals are going to be. And so I can imagine this starting to pay dividends. So anyway, that's the update on Chinese. All right, let's move on. Pierre van Obergen. Hello, Fraser. How come we are not living in a black hole? Because at the beginning, the universe was very dense and compact. Well, I mean, if we were living inside of a black hole, we'd probably be dead. So the fact that we aren't means there's something happened that didn't make the universe become a black hole. And I think it's kind of interesting. I've mentioned the stat before that if you take all of the mass in the entire observable universe, it actually creates, and you made a black hole that contained that much mass, energy, dark matter, everything, it would make a black hole with a event horizon that's about the size of the entire observable universe. That's weird, right? Just a coincidence. Just like the moon and the sun are the same size in the sky, it's just a coincidence. But so why didn't the early universe just turn into a black hole? And we've talked about this a bunch of times, but the gist is essentially to have a black hole, to have matter turn into a black hole, you need to have an overdensity in one location. And so the problem was that the early universe was so evenly dense that matter couldn't compress into any one spot. You can imagine it was being pulled. Every particle that tried to move towards another particle so they could all start to become a black hole, they're getting pulled in the opposite direction by other particles forever. And so there just wasn't enough overdensity in any one spot for it to be able to turn into a black hole. Visto Tutti, NASA plans for nuclear propulsion in space. Does that fall afoul of the space treaty? No. Having nuclear material or a nuclear reactor in space does not fall afoul of the Outer Space Treaty. The Americans have actually launched a nuclear reactor into space in the past. Of course, like an actual fission reactor. The Soviets have done it many times, 20, I think. One of them crashed into Canada, and we have like debris from a Soviet era satellite space-based fission reactor. Works well though. Putting a fission reactor on a spaceship is a really good power system for a spaceship that you can't use solar power for. The other obvious one is, of course, the nuclear RTGs, but they're more like a battery. Like you're just essentially letting plutonium decay. You're taking the heat off of it and using that to run electrical devices, which is different from an actual fission reactor. And so, we reported on Universe Today about this. And so there are plans to send fission reactors into space in the coming in the next few decades. And it's the kind of thing that you would need the farther out you go into space. Like if you're going to hang out here around the Earth, solar power is fine. But if you're going to go all the way out to Mars or especially Jupiter, Saturn, the outer planets, you need a lot of power, and that power can't be solar power. It's got to be some form of nuclear reactor. It could be an RTG if your power requirements aren't that high, or it can be a fission reactor if you need to. So NASA has got this thing called the kilopower, and they're thinking of deploying this on the moon. And so I think that at this point, nuclear reactors, fission reactors in space are going to be inevitable, but there will definitely need to be some kinds of requirements about where you launch them, how far they go, what are your safety concerns, and of course, no nuclear weapons. And that's the thing that's really the key is no nuclear weapons in space. You can't go, if you deorbited a fission reactor in space, it would make a mess. It would land in Canada and we would have to clean it up and send you the bill that you never paid. But it's not going to be like a nuclear weapon that's designed to detonate in the airspace above a city and cause enormous damage. And so that's sort of the line is no weapons in space. No weapons. You can't use rods from God. You can't use nuclear weapons. You can't have targeted energy weapons. No weapons. But other stuff are permitted. All right. Claire Hill. Oh, this is such a great question. All right. So have you ever thought that there could be intelligent life on other planets, but they have constant heavy cloud cover, so they have no idea about space? That's so cool to think about that. And the answer is almost certainly that there are places out there in the universe which, for whatever reason, any life forms that exist on that planet will have no knowledge that there is such a thing as space. There's only the atmosphere, and there's cloud tops above them. And if they never build any kind of flight capability, then they would never know that you could fly above the cloud tops, and then you could see space itself. But at the same time, or I'll give you another example, right? Imagine there was creatures that lived, say, under the ice on an ice world like Europa or Enceladus, where their world is water, and they know that there is this dome above them of ice, and they start to drill through this ice until they reach the surface. And as they go, the pressure levels get harder and harder for them to deal with, and they have to wear spacesuits. And so it gets trickier and trickier for them to be able to survive. You can also imagine, say, some kind of life form that lives maybe on an ocean world that's warmer, and they live on the bottom of the ocean, and they can't handle being up onto the surface of the world. So they have to create like a spacesuit that allows them to be able to survive on the surface. And so for the vast majority of life forms, they will have clouds, they will see space, they will see stars, but there will be some that their concept of their place in the universe will be utterly different from how we see it. And not just necessarily in terms of sort of what planet they could live on, but also in terms of like time. In the far, far future, you could imagine future civilizations won't be able to see back to the cosmic microwave background radiation, will fallen over the cosmic horizon. You can imagine a civilization that lives on a field star, so like an individual star that is not associated with any galaxy. They'll have no stars in the sky, and they won't necessarily see other galaxies unless they build telescopes. But they won't know to build telescopes because nighttime is just darkness, and then there's the sun. So there's been some great books that I've read that sort of cover these different concepts of just how does living on a planetary system that doesn't have the same just rhythms that we all take for granted here, how would that impact your perspective on the universe? It's fascinating to think about. Dwayne asks, since Saturn is about 30 minutes farther than Jupiter, what does that mean for the conjunction? Do they actually align earlier or later than what we're seeing in relative terms? That's a tough one, because essentially the conjunction is about the Earth, Saturn. No, it's about Saturn and Jupiter lining up from the perspective of the Earth, where the Earth is. And in fact, before the conjunction, I asked Dave Dickinson, who's our amateur astronomy beat guy on Universe Today, to try to give us like a really precise time for when the conjunction was going to happen. And he wasn't able to do it because it just, like, they spend a lot of time very close to each other in the sky. And they're moving around the sun and we're moving around the sun. And so for them to sort of define like what is the point where they're all lined up is actually, it's not a very easy thing to figure out. And I guess, when you think about it's like the time, yeah, when you're looking at Jupiter in the sky or when you're looking at Saturn, it is some number of minutes away. The light has taken some time. And so it's not actually there. But then what does actually there mean? Because we live based on when we can observe things in the universe. So you'll drive yourself crazy trying to think about how things could have been in the past when we could have seen them back then. All right. Stephen Miller, do you agree that to find truly Earth-like planets, we need a new Kepler that has a life of 8 to 12 years to get enough signal? Kepler died too early. TESS doesn't collect enough data on each star. Yeah, so let's talk about Kepler here, right? So TESS is the satellite that is finding all of the planets that are lined up around all of the nearby stars. And it's actually a very inexpensive satellite. I think it costs like $200 million, relatively speaking. That's cheap. Kepler was a flagship. Kepler was a really, really big, powerful telescope that was designed to stare at one tiny portion of the sky, just trying to just work out every single star that was moving in some way based on the fact that it had a planet, or every planet that was dimming slightly because a planet was passing in front of it. And unfortunately, of course, Kepler's reaction wheels died, and so it wasn't able to complete its primary mission as long as it was needed to. And I'm kind of torn. I mean, like, do I think that we should have more powerful planet hunting telescopes? Absolutely. More are in the works. But I'm a lot more excited about the potential of things like astrometry as a method for finding planets than necessarily things like the transit method. So one of the capabilities of the Gaia mission is that it's going to be able to turn up tens of thousands of planets orbiting stars in space, because it's able to detect the motion of a star as the planet is orbiting around it, essentially yanking the star in a little circle from our perspective. And so it works if the star is face on, if the star is like at a bit of an angle. It'll even work if the star is edge on, because you're going to see the star sort of go back and forth from that point of view. So it seems like astrometry is actually a much more effective methodology for being able to find planets than for large numbers. But there was a study that I looked at, and we did a video about this, that, if you take the planetary discovery rates, you just ramp it up, that it's expected that we'll see somewhere around 50 to 100 million planets by about 2050. Like 30 years from now, we will know of tens of millions of planets. And there will be entirely new surveys and techniques to be able to get at that level of planetary discovery. So Raphael Dominichini, if mining from other planets or asteroids is not viable in the near future, what else can motivate humanity to colonize elsewhere? Why does humanity need to be motivated to colonize? Earth is the best. Like everything else, go live on the Faroe Islands, or go live like places that are difficult, harder, right? We like to live in places that have reasonable climate, that have water, that have nothing disparaging the Faroe Islands. I'm sure I want to visit that. It looks awesome. Seems cold though. Not a lot of trees. So and it is a million times more hospitable to human life than Mars or the moon. And so I think that I don't think that there is a good reason to colonize another planet yet. There's good reasons to set up science bases on those other worlds, like, um, you know, wouldn't it be amazing if you could look up at the moon and know there's astronauts living on the moon, and you look up at Mars and you know there's astronauts living on Mars all the time? That'd be incredible. But I don't think that we want to send large amounts of humanity to these other worlds until our technology has trivialized existence on those worlds. So, um, like right now, every moment of survival will be incredibly fortunate with our current level of technology. But there'll be some future time when it's trivialized. When we've got nano factories that produce material on an as needed basis. We've got incredible composites. We've got powerful energy, compact energy sources. And so kind of in the same way that living in the desert or the cold has been trivialized by our technology. That's what it's going to take. That's when it will become feasible to live on a world like that. Warbash. I wonder if dark matter might be a bad name and kind of sending us in a bad direction. If you had to, what would you rename it? Stretchy matter? Crazy matter? That's good. Yeah, I mean, dark matter I would call it invisible matter, which is a terrible name too. Mystery. Because like you could go the gravity route and you could say like extra gravity, weird gravity, more gravity. But then you tack on top of that the idea of dark energy, which I'm sure someone was like, oh yeah, we've already got the word dark matter. Let's call this dark energy because it's kind of appropriate. But that just makes it even more confusing because now people just disbelieve them. They put them in the same bucket. Dark matter, dark energy. Well, they're two completely different things that probably have nothing to do with each other. But now because they got the word dark in front of them, people got to use it like that. So yeah, I don't have a better name, but Horizon Brave, what caused you to learn Chinese Mandarin? Choose Chinese Mandarin to learn. There are about 1.1 billion people that speak English on planet Earth. And there are about 1.1 billion people who speak Chinese on planet Earth. So it is like an enormous, and I already speak some Spanish and I already speak some French. So I've sort of locked down many of the world's languages, and it was like always just this blind spot. And I was always just kind of I don't know, it's just like there's this entire culture that has as much history and books and TV shows and video games and anime and manga and all this kind of stuff. I know I'm using the Japanese word for a type of Chinese story. Anyway, and look, I had no connection to it whatsoever, and so I'm just curious. That's like the first thing. The second thing is learning languages is good for your brain, and so I have to actively force myself to go into places where I'm uncomfortable. I think it's really important for us to do that with what we know. And so I like learning a new language is hard, and hard things are good. And I couldn't think of a thing that's harder. So that's why I did it. I did it because it's hard. And then the other thing, of course, is that they are responsible for like half of the rocket launches that are happening around the world. They are a huge portion of the future of space exploration is going to be originating from that one country. And so it made sense for me it felt like a total blind spot in my ability to do journalism as a space journalist. And so I wanted to be able to fill that gap. And I think that's going to be the easy one. The easy, it's just going to be the easy part of like being able to just read. Like obviously I could just translate. I could just throw these things into a translation tool and they're really good these days. And I could read press releases and read Weibo, but I'm sort of just not steeped in just sort of the social media space in the way that I am in attempting to learn it. There's all these other little pieces of the puzzle that I'm picking up. So that's kind of all the reasons why I decided to try and learn it. And who knows whether I'll actually pull it off. But I feel like so far my momentum is good for me to keep going. AAU. Hey, Fraser, assumed a crewed mission to Mars. What is your best guess as to where the next landing will take place? Mercury, Venus, main belt asteroid, Callisto, somewhere else, or nowhere? Yeah, so I would say we're going to see the moon and Mars are the obvious destinations for a human mission. After that, I'd probably say asteroids. I think we definitely need some kind of human mission to going to like Totatus, right? Or Apophis or something like that. Like there are a lot of asteroids out there that potentially have our name on it, and we should be able to land some humans on there. I also think it would be really useful to land on Ceres, but that's starting to get a little far out into the solar system. But like, a great big asteroid that has clearly like some kind of it's the closest ice world that we have, and it's really fascinating. And so I think Ceres would be good. I think Phobos, the moon on around Mars, would be really interesting to send humans to. But there aren't a lot of real locations to go to send humans to at this point. But I can imagine 200 years from now, we will have a base on the moon, a base on Mars, a base on Ceres, a base on Phobos, and maybe a base on a couple of other asteroids. And that's about it. Because I don't think that anyone's going to want to live anywhere but Earth for long periods of time. And then, of course, eventually we will build our giant O'Neill cylinders. Our technology will have trivialized living in space, and then the vast majority of humanity will live in space in giant climate-controlled O'Neill cylinders with 1 trillion people living in space. A.V. Scott and Flower. Could any form of astronomy detection discover super heavy elements from the island of stability, artificial elements or unknown isotopes around supernova, black holes, exoplanets, star formations? Probably not. So we know about all of the elements that are currently on the periodic table of elements. And then we know that there are heavier elements in the periodic table that we have been able to create in particle accelerators. And at a certain point, they start to fall apart within a fraction of a second. And things may be a little more stable, a little farther in. But as you said, that there are vastly more powerful particle accelerators out there in the universe. Black holes. A black hole, when a black hole is formed, when a supernova forms, collapsing all that material inward, then for a moment there are going to be atoms created that are way beyond anything that we've ever made. Like you can imagine atoms with 1,000 protons and neutrons. I'm sure there's all kinds of crazy stuff. The most powerful supernova that have ever happened have created the most heavy elements. But the fact that we don't see them today means that they fall apart instantaneously. And so we know that we will never be able to match the capability of a thing like a supernova. Kronos 776, is NASA planning missions to Neptune? There's one mission that's in the works called Trident, but hasn't been approved. NASA has to choose between this Trident mission, which is going to go to Neptune's moon Triton. It's just going to be a flyby, or they have to choose a mission to Io, or they have to choose. They have 2 possible missions to Venus, so you get to pick 2. 2 missions to Venus, mission to Io, a mission to Triton. Choose 2. That's where NASA is right now. And based on all of the exciting stuff that's happening on Venus, I can anticipate that Venus is going to be the place that gets chosen, which it should be because nobody's gone to Venus. And they better hurry because I'm going to have Venus pushed into the sun. All right. Hemp Tech. Despite taking a long time, should we send a probe to Alpha Centauri? Yes, even if it spends 50,000 years getting there. We could put optics on it, etc. So should we send a mission to Alpha Centauri? No. We shouldn't send one until we can think we can do it in a reasonable amount of time. Every year that goes by, our ability to send probes faster and farther into space gets better and better and better. And so imagine you send a probe to Alpha Centauri, you send it at the fastest your technology will let you do it, and then 10 years later, your technology is now so much better that you can send a new spacecraft and it'll arrive sooner than the one that you sent 10 years ago. And then you wait 10 more years and then you send it even faster and it gets there sooner. So this idea, you want to come up with this time when you can send a probe to Alpha Centauri at the point where you can anticipate that you will never send a spacecraft that goes faster. And this idea, it's called the wait calculation. And essentially there is a mathematical formula that you can use to figure out how long you should wait before sending a spacecraft to Alpha Centauri or anywhere in interstellar space. So you need to follow that calculation. If you're going to send like a giant interstellar probe, I think the number is like 700 years. We did a video on this anyway. And until then, and it'll take you about 40 years to get your spacecraft to Alpha Centauri. So if you send one any sooner than that, your later technology will arrive first. Darren Nolan, I wonder what the night sky might look like on a planet that's at the top of the galactic plane over the galactic bulge. That's interesting. I mean, the first thing is that, we are inside the Milky Way. We are trapped in the middle of the Milky Way, and yet you need to be having perfectly clear, dark sky to be able to see the Milky Way at all. If you've got any light pollution, you can't really see the Milky Way that much. And so it's not like we would see anything dramatic of the galaxy itself. It would just be, there'd be a little more of a, and in fact, because it's not concentrated and you're above it, then it might actually look a lot more diffuse and widespread, almost like there's like a cloudiness in one direction of the sky that you don't see in the other direction of the sky. And then as in terms of stars, I mean, we see stars in all directions, even though theoretically we should see more stars towards the disk of the Milky Way than we do. We see stars above us and below us and in all directions. And so you would anticipate that if you were on the galactic bulge, you would see the same thing as well. A couple people asking about the conjunction. We're not going to be able to, the conjunction is happening right now. So it's, it started earlier today and is continuing to go. And unfortunately, we weren't able to get the weather gear, planetary alignment to be able to do a live stream. We tried, but we weren't able to pull it off. So unfortunately, everybody reported bad weather. The sky's just cleared here, so maybe I'll be able to go see it with my own eyes. Bannon Greylorn, any updated info on O'Neill cylinders? They seem just a better idea than going to the moon or Mars. What are your thoughts on this? Now, I have a poster behind my head that says the gravity wells are for suckers. So I definitely agree with the idea that, we don't want to go live on the moon or Mars. Once you've gone to all that energy to get out of a gravity well, why would you go into another one? It's crazy. It's like climbing to the top of a mountain and then climbing down a mountain so you can climb up another mountain. That's madness. But we don't have the technology. We don't have the technical infrastructure to be able to live in space, to be able to handle every single part of what's required to keep humanity alive. We don't have the we don't have the ability to generate a completely closed oxygen system, to be able to perfectly recycle wastewater, to be able to handle heating, cooling, and then all of the weird, complicated things are going to happen that will come up. We don't have the ability to create artificial gravity through rotating cylinders. There's so much to do. So there will come a time when our technology trivializes it, and that will be, it's going to be longer than you hope. It's not going to be in your lifetime. It's going to be hundreds of years from now. And when that happens, then it will take off quickly, and then there will be an enormous number of them. That eventually a Dyson swarm will be generated that's filled with O'Neill cylinders that's surrounding the sun, and the solar system will look very different from how it looks today. But for the foreseeable future, we're going to be living on Earth. We're going to have some research stations on the Moon, Mars, Ceres, as I mentioned before, a couple other places, and that's going to be awesome. And we're going to have to make do with that, and just know in our hearts that some future civilization will be living in rotating O'Neill cylinders. Torn Atkinson question, maybe not your area of expertise, but if the universe is a simulation, how, if any, should we change our behavior? I suggest not at all. Torn, let me know if you are going to do a podcast. I'm happy to come back on the show. So the simulation argument, I mean, obviously I'm sure you're all very familiar with it. And yeah, I mean, it's a great idea. It's an interesting sort of thing to rattle in your brain. But the reality is that because the simulation gives us no way to actually detect whether or not we're living in a simulation, we have to just assume that we live in base reality until evidence shows us otherwise. So we have to live every day like this is the only life that we get. And we have to do as much with our time as we can to make the world a better place, to connect with other human beings, to have a meaningful impact, and to make other people's lives better. And I think that is the problem with any idea that tells you that this isn't reality, that there is some other reality that you need to be getting prepared for. And because it sort of takes away from how wonderful this reality is. So it's sort of like, it's like, that's how I feel about the simulation. I feel the same way about literally any, are we a brain in a vat? Is there a heaven? Anything like this life is the one that we know we have. So let's make the most of it. Apologies. That's good questions here. Brad McGashett. Do you think that it's plausible that aliens exist everywhere throughout the Milky Way galaxy as well as the universe, but 99.99% are just not intelligent enough to create advanced technologies? Even if you had 99.99% of alien civilizations not able to create advanced technologies, that would mean that there are, let me just do some math here, right? So that's like 1 in 10,000 planets have alien life. And if there are 400 billion, then that means there are hundreds of thousands of civilizations across the Milky Way. And all it takes is one of them to send out a fleet of robotic spacecraft that build self-replicating robot probes, and within 10 million years, they have created monoliths on every single planet across the entire Milky Way. So it would have to be much less frequent than 99.9, like 1 divided by 400 billion would be the number. And, I mean, maybe 10. If there's 10 civilizations, if there have been 10 intelligent civilizations in the history of the Milky Way, and none of them just happened to get going on the old robotic von Neumann probe idea, then that makes sense. But beyond that, that's where the full force of the Fermi paradox starts to come online. That what's weird is that we don't see any aliens here. That we don't see the monolith, we don't see the self-replicating robot factory in the solar system right now churning out von Neumann probes. And that's what we should see. That is the consequence you would anticipate of an intelligent civilization working hard to generate, to understand the galaxy that they live in. So that's where the full force of the Fermi paradox should sit in your mind, is where are the monoliths? Where are the robots that are turning the solar system into more robots? Where are they? And if it's impossible, if the reason we don't see any robots here because no other civilization out there in the entire galaxy was able to figure this out, then as a consequence, that means that we will never be able to figure it out either. It will become mathematically impossible. So can't have it both ways. Either either we're going to be able to explore the galaxy at some point in the future, and if we are able to, then it makes it even weirder that we don't see. Then we have to assume that we're alone. The second we're able to send a self-replicating robot probe off to Alpha Centauri, and it starts building more robots to go off to nearby star systems, is the second that we know that we're alone in the universe. The Einrib, will you make a special Mandarin episode of Q&A for the Chinese? Whenever I see the word Mandarin, I think Mandalorian. Anyway, yeah, that's the goal. The goal is for me to get to the point where I am fluent enough to be able to answer questions in Mandarin Chinese. That's sort of like as I set as my plan. For fun. It will suck, but and it'll take me a while. Some people are asking some questions that I don't know the answer. But Douglas Smith is asking, what is the expected terminal velocity of SpaceX Starship as it performs the belly flop? I don't know. Does anybody know, maybe in the chat, what the speed of the the terminal velocity speed of Starship was as it was coming back down? Because that's essentially, I mean, I think they launched Starship with SN8 to the flight so that it could then belly flop and reach terminal velocity and then test out the landing procedure. That's why they flew that high. But I don't know what the speed it was going when it kicked down the boosters to land. But it'll be going from orbital velocity to terminal velocity. It's got to be able to make it through that speed domain. Teox Trader, is there a way to push Venus into the sun? Absolutely. The way you would push Venus into the sun is that you would set up an asteroid that is on a circuit between Jupiter and Venus. And so every time the asteroid would come down, it would do a gravitational slingshot around Venus, and it would essentially steal a little bit of orbital velocity from Venus. And then it would fly back out, and you'd have to time it so that it would go around Jupiter again. It would pick up some orbital velocity from Jupiter, come back down, and then steal a little more from Venus. It would take you, each flight would take you a couple of decades, but over long periods of time, you would continue to steal orbital velocity. Venus would get closer and closer and closer to the sun, and eventually it would burn up. So yeah, absolutely. There's a way for us to get rid of Venus, no problem. 6 Bob Ohms, Fraser, on to important questions. How do you like The Expanse season 5? Thumbs up, down, mix? I'm enjoying it a lot, but I think I have Expanse colored glasses right now, and I think the three episodes that they released as opposed to releasing the whole season, that is uncool, man. So we watched them, we're like, that's great, so that's tonight. Tomorrow though, there'll be chaos, and so we had to go watch something else. It was heartbreaking. So yeah, absolutely. The Expanse season 5, The Expanse. Is The Expanse the best science fiction television show that's ever been made? Maybe. I don't know if that's the hill that I will fight on. But if someone made that case to me, I wouldn't have an argument with them. Joe Kozak, is Hubble going to Saturn and Jupiter tonight? That's a good question. Hubble's field of view is too small to be able to show Saturn and Jupiter together, but there are other telescopes with a wide field of view that might do a really good job to view Saturn and Jupiter during the conjunction. But I mean, amateurs have been doing an amazing job of it. Corey Schmitz did a live stream today where he was able to show it. It looked great. So, Teox Trader, how big were the population 3 stars? Mr. Mann says, I am the Orville in Stargate. Yeah. Yeah, see, I wouldn't argue. If you said Stargate, Orville, or is Orville like the best science fiction story on television? No, it's a really solid Star Trek series, though, for sure. But is it the best? No, no. Rick and Morty, though. Anyway, if you haven't watched The Expanse yet, you are uh, you're missing out. Right, text trader. How big were the population three stars? So the population three stars were the first stars that formed in the universe after the universe had cooled down to the point that stars could form. And we don't really know how big they were, but we know that they were big. I mean, they were essentially just made out of primordial hydrogen and helium left over from the Big Bang, and like a little bit of lithium. And without the heavier elements inside of them, these stars could get much bigger. They were able to form very quickly and be able to form without these really powerful solar winds that blast away additional materials that's trying to fall in. And so I've seen simulations. I mean, the simple answer is that they were in the hundreds of times the mass of the sun, but I've seen simulations of like what would a supernova be like if the star was 60,000 times the power of like 60,000 times the mass of the sun. And so I don't think astronomers have really decided on how big these stars were. And this is like one of the regimes that astronomers have no access to yet. That there are no telescopes that allow us to see those first stars in the universe. James Webb will be there to help us see the first galaxies in the universe. There are some radio telescopes that allow astronomers to see the dark age period between the cosmic microwave background and those first galaxies coming together. But before that was the first stars, and there is no current technology. Of course, there is a telescope that's being planned that would let astronomers be able to see that, and that's LUVOIR. So if you can go up to a 15-meter observatory, then you will start to be able to see the sort of the cumulative effect of those first stars and their supernova and things like that. And so it's another good reason why you want to go up to a LUVOIR-sized telescope or bigger. And that's like the last domain in astronomy. That takes you right out to essentially the edge of the observable universe. And I'm sure you're wondering, like, why can we see the cosmic microwave background, which is even farther than those pop three stars? And that's because the cosmic microwave background is everywhere. That is in all places, as opposed to single point source stars. So the cosmic microwave background is the energy released by the entire universe towards us, while the population three stars are, individual points of light, and so they're tricky. So, it's important. All right, so we're nearing the hour, but this is like episode 100. So should we just keep going? Does anyone want me to stop? Anyone had enough? I'm gonna have a drink of water and I can keep rolling. All right. Michael West asked, if you were the head of NASA, what would be your top 5 missions that you would love to do? I mean, I want to send a mission back to Venus. I definitely want to send a mission to Titan, although that's in the works. I definitely want to send a mission out to the to Neptune or Uranus and their moons. And mission to Phobos, although the Japanese have that in the works. Yeah, I don't know. It's tough. See, and as it relates to human spaceflight, like my perspective is that I'm more interested in I'm super interested in just this idea of increasing your capability. So as opposed to like, let's go to one specific target and let's like build the entire mission plan to go to this one place. Let's just build up our capabilities, our technology, figure out all the rough spots that make it difficult for human beings to survive in space for long periods of time. But Nancy, if you're getting tired, feel free to wrap up if you don't want to keep going. I'll go for a little bit, but I don't want to. I definitely don't want to sort of make Nancy work overtime. So I can totally pull the questions from the chat if I need to. Andy Griffiths, will remote-controlled drones robots replace human space exploration? Yeah, I think to a certain extent, we will settle on their most science-related jobs are good for a spacecraft, for a robot. But then there are going to be certain things that are only going to be good for a human. But the main reason to send humans to space is to learn how to send humans to space. Like, I know that sounds like a tautology, right? But I think that if you're trying to do science, robots can do science better than any human will be able to do over the long period of time for cheap, and it's safe and so on. But if you want to be able to, if that future of humanity is at some point for us to have humans in space, then we just have to send humans to space to learn how to send humans to space. That is the purpose. And so I really kind of bristle when people try to provide any kind of justification for why to send humans to space, right? Like, it's not for science. Robots can do science better than anybody ever. It's just you send humans to space because how will we learn about sending humans to space unless we send humans to space? All right. Michael West, what is your favorite mission idea that never came true? I've mentioned, I did a video about missions that never happened that I'm sad about. And the one that, the biggest one, the one that anyone's listened to Astronomy Cast knows that we whine about, the terrestrial planet finder. So back in the late 90s, early 2000s, they built an idea for a mission that was going to be 4 space-based telescopes, kind of like Hubble telescopes, but they would fly in formation like an interferometer. And so they would act like a telescope that was vastly bigger. And so then they would be able to be capable of observing Earth-sized planets orbiting sun-like stars. And just the idea of an interferometer in space is awesome. And it sucks that it never got built. Got canceled, never got built. And so now we've got James Webb, we've got LUVOIR, but this would be better than LUVOIR. This would be next level. And it just never got built. Never got, the planning stopped, which is too bad. Steve Wolfhope, do you have a backyard observatory? No, I don't. I want to build one at some point, but my weather here is so bad. So I love to be able to use the observatory down in California, thanks to Oceanside Photo and Telescope. Although that has its downsides too. Like, it's been really tricky. We had all kinds of technical problems with that observatory, being able to access it. And because it's in the middle of a desert in another country that I can't go to because of a certain pandemic, if the telescope stops working, that's just too bad. Well, if it was in my backyard, I'd be able to go and mess with it. So I think at some point I'm going to get around to building an observatory in my backyard, but that'll be probably a couple of years from now. There you go. People are saying terminal velocity for SN8 was 66 to 68 meters per second. 6 Bob Ohms, what do you think about ESA's new reusable concept for covering engines with little wings and propellers landing on the runway? I think it's all fine. Any attempt to recover any part of a spacecraft is the right way to go. But seriously, we can see that the future is going to be the Starship, right? A 2-stage, fully reusable rocket where no part of it is thrown away. That is the future. And it might not be the way exactly how SpaceX is expecting it's going to go, that they might have to use more energy on their deorbit burn to stop the thing lighting on fire as it comes to the atmosphere or something. Someone's going to crack this. And I wouldn't spend a second working on any kind of technology other than a 2-stage reusable rocket system. You're wasting your time. Everything. I mean, like, I see United Launch Alliance. They're using, with the Vulcan, they've got reusable rocket engines while the fuel tank burns up. That saves a lot of the cost. But Starship will just land, and then they'll put a new cargo in, and it'll just take off again. They'll fly, each one will fly hundreds, thousands of times. They're just, it just feels like Elon Musk and SpaceX has cracked the code, has gone from first principles and said, this is what is the most efficient, effective way to make a rocket go. Now, Raphael Dominichini is saying, what if Starship doesn't work? Yeah, if Starship doesn't work, then that whole idea was a wild goose chase. But I think that even if SpaceX fails to figure out how to make this idea work, like the technology that SpaceX developed that proved is to make rockets land vertically, that the new ability to turn off engines, to be able to control your descent, to be able to relight your engines, and to be able to have artificial intelligence, essentially be able to control a rocket in a very complicated way so that it can land safely. That is the quantum leap forward that SpaceX brought to the game. And so now the question is, will other people be able to improve on that idea in a fully reusable rocket? And maybe you're going to have to make a bigger rocket. Maybe you are going to have to have some kind of removable heat shield. I mean, we saw the space shuttle. Space shuttle was able to fly back from orbit, pass through the atmosphere, land on a runway. So imagine if a space shuttle passed through the atmosphere and then landed vertically. So I think that now it's an iterative process they're going to be able to reach the answer to. The big question is, can they make these things re-enter the Earth's atmosphere? And that is still the big unknown. But I think somebody will be able to figure this out. And so no, if I was Europe, if I was United Launch Alliance, if I was the Chinese, if I was the Russians, I would, and I wanted to launch big payloads, I would only figure out how to build a 2-stage reusable rocket system. Like maybe don't do it out of stainless steel. Maybe do it out of composite, carbon composites. Maybe that was the right idea. We don't know. But I think if you can't make a fully reusable rocket, you are battling last decade's. You're in last decade's race, and you're gonna lose. Okay, so Richard's workshop. Do you think that it is currently possible to build a mostly self-sustaining colony on the moon or in space to support research and astronomy with less additional resources from Earth? No. Any research base, I wouldn't even call it a colony, right? Any space station on the moon or Mars, like that's what you need to really be imagining, is that it's going to be a space station that happens to be attached to a world. Is going to require constant resupply from Earth for decades, and they're going to try to figure out how to be able to live off the land in terms of being able to harvest lunar regolith to make water and volatiles, or Martian regolith to do the same, or to be able to pull material out of the atmosphere. Like anything that you can make locally is going to be an improvement, but nobody has ever tried any of this ever at all. The Perseverance, as it's on its way to Mars, is the first mission that's ever been sent to another world with any plan for some kind of in situ resource utilization. It's going to have a little experiment on board called MOXIE that is going to draw in carbon dioxide from the atmosphere on Mars and attempt to turn it into things. That's it. No one's ever tried this before. And so we are decades, like here's how it's really going to work. Humans are going to go to Mars as part of, or to the moon as part of the Artemis mission. They're going to land a spacecraft, and then they're going to come back to Earth. And then some more humans are going to go a few years later, and they're going to land. They're going to look around. They're going to come back to Earth. And then someone's going to build something that's they're going to drop something that's kind of like a base, kind of like a space station, but it's going to be sitting on the moon. And then people are going to go live there, and they're going to be constant resupplies, and they'll be doing that for about 20 years or so. And then they'll start sending technology that allows some kind of in situ resource utilization, sort of in the same way that 3D printers and greenhouses have been sent to the International Space Station. And they'll test out these little ideas. They'll figure out what works, what doesn't work, and they'll build it out bit by bit by bit for decades. So we are 100 years away from people on the moon being able to be not entirely self-sufficient, that they'll be able to make some of the things they need locally. Same with Mars. Apologies. So Chimpy726, what about VASIMIR? I've been reporting on VASIMIR. So VASIMIR is a kind of alternative propulsion system that's been proposed that will cut the flight times down to Mars to just a couple of months. Yeah, I feel like I've been writing stories about VASIMIR for almost 20 years now. So I'm not sure exactly when they started to develop prototypes of the engine and its current state. These kind of new ideas for propulsion systems, they come out fairly regularly, but in general, people focus on chemical rockets. There's been like a couple of alternative propulsion systems that have been tested. Ion engines now are fairly in wide use, and the Japanese have demonstrated how useful they are, how good they are. But also and then like solar sails, people are just starting to test out solar sails. So I think it's going to be decades. We're going to see probably some high thrust versions of ion engines. And if VASIMIR, someone can test out VASIMIR in space and it works great, then that's great. But so far I don't, I am not hearing any rumblings that we're going to see it anytime soon. And, to be honest, there isn't a lot of need for rapid trips to places like Mars. I mean, there are definitely some need to send spacecraft out on longer journeys to be able to go out to, say, Neptune, Pluto. If you want a lander for Pluto and you want it to happen in your lifetime, you're going to want a fast rocket system. But not that useful close. I mean, yeah, you could turn a 6-month trip into a 3-month trip. Jurij Slavic. How bad is Starlink so far for astronomers? Isn't all that space junk going to ruin some of the advanced telescopes coming? Thanks. So just to let you know, I have signed up for a beta of Starlink. I paid. So they are shipping me out my Starlink. At some point in the next 4 weeks, 6 weeks, might be a little while. So I'll be able to give you an actual, real, proper test of how Starlink works here in Canada. And it'll be great to have a backup internet system because at this point we're totally reliant on the one provider, which is really good. I mean, I really like my internet. So is Starlink going to be bad for astronomy? Yes, Starlink is going to be bad for astronomy. Starlink is going to cause some telescopes to have a worse ability to view the night sky. It depends on how either like what their latitude is. So essentially when satellites pass into the field of view, they spend time sort of down at the horizon and they're visible, and then they pass into the Earth's shadow and then they disappear. But the farther you are north or south, the longer satellites will remain visible across the entire night sky. And so here, for example, in Canada, when we take pictures, we see satellites all the time. And I'm sure the people down in Chile, like at the big observatories, they'll see the same thing. But when you are sort of in more of the mid-latitudes, things like, say, Mauna Kea, it's not as bad. And then the other thing is like, have you got like a really wide field of view? And so the one that's really bad is going to be the Vera Rubin Observatory, which is in Chile, fairly far south. So it's going to have a lot of Starlinks passing through its field of view, has a very wide field of view, and it's taking a lot of pictures. And so it's going to take a picture and there's going to be a Starlink trail passing through it. It's going to take another picture and there's going to be a Starlink or 2 Starlinks. It's going to happen all the time. Sorry. Yeah, absolutely. And so in general, these satellite megaconstellations are a net negative for the field of astronomy, like no question, and not just visual astronomy, but also radio astronomy. And that sucks. But we are getting reports of say Aboriginal communities here in Canada who are getting access to Starlink for the first time. And literally for the first time, you've got cities of 3,000 people who have not had any accessible connection to the internet. That for 20 years, our telecommunications companies have dropped the ball in delivering internet to these far-flung communities. And so you've got 3,000 people, their children can't get access to knowledge. They're having trouble accessing healthcare, and especially during the pandemic. And you're hearing now suddenly where they had dial-up speeds, now they've got 150 megabit speeds. And suddenly they get to join modern society. And so I think that the challenge of something like Starlink is just these two, like, on the one hand, astronomy is going to suffer. No question. Indisputably. On the other hand, a huge portion of humanity that wasn't able to access the internet is now going to be able to access the internet. And now we know the pricing, right? It costs, in Canada, I think it's $750 for the base station and $130 a month for connectivity, which is expensive. Although I pay $120 a month for my internet, which, to be fair, is really, really fast. I have a gigabit internet because you deserve nothing less. So it's double the price of regular internet. But for a community, you can imagine them taking one 150 megabit download connection and then sharing that among a bunch of houses. And now it's cheaper than the terrible connection that you'd be getting from your telephone company. So there is not a simple solution to this problem. Humanity needs internet. Satellite internet seems to be the one that's going to deliver to every corner of the earth, and it's going to make astronomy worse. And you can't just simply say, oh, well, we should just launch space telescopes. Like, that's not a solution, right? So much of astronomy is done from down here on Earth. I think what we want to see is some kind of collaboration. Like, let's have some zones where Starlinks rotate themselves so that they are not visible as they pass over the observatory complex in South America. I think there are some compromises that can be done. And I think that that it's too bad that the satellites already launched before people had a chance to have a really deep and meaningful conversation about what it is that we're giving up in exchange for this thing that we really want. And now, fortunately, Starlink and SpaceX has been really good to negotiate with the astronomers to say, okay, let's try painting these satellites black. Let's try putting on covers so that they don't reflect in the same way. But I'm always frustrated by what I think are very simplistic arguments on both sides of this. Like, I think can you really say that your ability to observe a supernova is more important than an Aboriginal community in Canada getting access to the internet so their children can do telemedicine? Right? And like, what is the solution to provide internet to these? Is it going to be more radio towers? Is it going to be 5G towers everywhere? So I think it's a really, really complicated problem, and yet it is going to be, it's what's going to happen. And so we need to sort this out. We need to come up with a great compromise. It is another commons, like the oceans, like the rivers, like the air. And we have shown that we can't take care of these things together, collectively, as humanity. We can't just like recognize that there was a cost to pumping carbon dioxide into the atmosphere, and that people are going to have a tantrum because they're going to have to pay to bring it back out again. That we can't recognize that there was a cost to dumping plastic in the oceans, and there is a cost to ruining the night sky. And so if these are the things that we're going to decide are important for us, humanity, to move forward, then we have to face that in and come up with compromises that share that resource properly. And we've seen this happen many, many times before. And my hope was that we would figure it out in the future. And so far we haven't figured it out. So, A.B. Scott and Flower, prawn for everyone. Come on, speak honest here. high speed, planet-wide. All right, there you go. That is my rant on Starlink. Larry Beckham is asking, what can Starlink do upstream? I will tell you. I will find out what it can do. So just farther on this, A.V. Scott and Flower is saying, will Vera Rubin be particularly impacted from Starlink in its quest to find Planet 9? Could corrective software be developed? So what Starlink is going to do to telescopes like Vera Rubin and other ones is it's just going to degrade their performance. So imagine Vera Rubin takes a picture of some chunk of the night sky and it gets a Starlink trail passing right through a comet or an asteroid. They have to take that picture again, or they have to take another picture and they have to remove the strip. They have to essentially ignore the strip that had the Starlink trail passing through it. And then they have to take another picture and hope that that one has that data that was covered up. And it almost certainly will. And so you're going to need just more time spent. And so it's like friction. The way to just describe what this is going to do to our ability to see the night sky is it's just going to cause friction in the amount of time it takes for us to gather these images. Say you wanted to take 9 images to be able to image that supernova or catch that supernova in action. Now you're going to need 12. And it means that it will sort of degrade across the board the ability for big telescopes to be able to do their science. And that's bad. So all these astros saying, also to what extent will Aboriginal community knowledge connection to the night sky be impacted? Don't worry about what these mega constellations are going to do to us personally in terms of being able to see the night sky. Like if you went out on a really dark night in really dark skies and you really tried to look, you would have a hard time seeing a Starlink. They're already very dim, right at the very edge of what the human eye can see. Painting them black, putting on this visor is going to make them literally invisible to the naked eye. You will not see this grid of dots moving in the sky like you're living in the simulation. It's only astronomy that's going to be impacted, but it is going to be impacted heavily. Dwayne Duval is saying, don't they have algorithms to remove the artifacts? If not, it should be soon enough. Yeah. Astronomers remove star trails, remove satellite trails, airplane trails from their data all the time. This is a solved problem. But you can't get back this streak of really bright light that passes through. So there is no algorithm that can get at the data that was behind that Starlink as it passed in front of your supernova. And so you have to take 2 pictures. You take one picture, and then you come back later, and you take another picture to get that missing strip of data. And so now you've got let's say you lost 5%. You get one Starlink trail passing through your picture, and you lose 5% of your whole picture. And so then you say, well, do I want that data? Because now I've got this strip passing through where I have no information. So I have to take another picture. So now I've got that missing piece, and then I've also doubled up on the rest of that data. And so that's what it looks like. And yeah, absolutely. All the astrophotographers in the house, they understand how to remove those trails from their images. You throw out the entire frame, or you have an algorithm that will strip out that one little piece of data and stack it up with all the other frames that you've got. And for us as amateur astrophotographers, it's no big deal. It's fine. It looks great. But for the professionals, it is like they have a bucket of data they're trying to fill up. And before they could fill it up to 100%, and now they can only fill it up to 90%. And then when they hit 42,000 satellites, and when OneWeb launches, and when the Amazon version of this launches, and then the Chinese version of this launches, and then the Russian version of this launches, maybe they can only fill it up to 50% or 20%. Like, it's just going to get worse and worse and worse and worse over time. In the same way that light pollution makes our ability to see the night sky just get worse and worse and worse over time. But with light pollution, you can go away from a place that's heavily populated and not have light pollution. With radio emission pollution, you can go to a place that's a radio quiet zone, but you can't get away from satellites passing overhead. All right, there you go. All right, we'll do just a couple more questions, and then I think I will. Now I'm getting tired. How do those Twitch streamers just go all day? Mark McDougall says, could you extrapolate backwards the motion of the stars and make a map of the actual locations of the stars in the night sky? The stars aren't moving that quickly. So when you look at the stars in the night sky and you see the stars where they are, maybe the light has taken a couple of hundred years to get to you. Maybe the light at the brightest, most distant star has taken a couple of thousand years to get to you. Most are in the tens to early hundreds. Stars don't move that much in 10 years, 100 years, as they move across the sky. But there was a great release from the Gaia mission that showed all of the motion of all of the stars in the sky. And so over long periods of time, over thousands of years, tens of thousands of years, millions of years, the entire night sky shifts and looks completely different. And that is, it's kind of amazing that the night sky that we see, the constellations that we see today, are just a snapshot of the time that we're at. And that if you went back 100,000 years, or if you wait 100,000 years, the night sky, the constellations will look utterly different. There might be a couple that are still sort of recognizable, but by and large, they're going to be totally different. And so one of the coolest things that was released from Gaia, from the Gaia data release 3, was this incredible map of the stars moving across the night sky. Past and future, because Gaia tracked the location, the movement of a billion stars, and then you get to play that in an animation that looks like just a bunch of fireflies buzzing around, and yet each one of those fireflies is actually a star zipping around. We get stars passing within, pretty close to the sun every 30 million years or so. And so it's kind of amazing. This is something that I sort of think about. It's if you could go all the way back for hundreds of millions of years, what would be some events, some times when comets passed right through the atmosphere? Every 100,000 years or so, a comet passes right through the atmosphere of the Earth and then goes back out into space. Not a few astronomical units away, right through the atmosphere. Can you imagine that? Looking up and seeing a comet all the way across the sky. There's times when stars get really, really close. There's times when there were, stars were way brighter than anything we see. Supernovae that went off really close by, that would have lit up the landscape like it was daytime. Anyway, hopefully we'll get to see some of these stuff in the future. All right, well, we've got the 6:30 mark, so I'm definitely going to call it now. Thank you, everybody, for all of your support and assistance and questions. Thanks, of course, to Nancy Graziano. I don't think I'll do another one until the new year. So I hope you all have a great holiday and a great new year, and I will see you in 2021. If you want to still stay in touch, subscribe to my newsletter. Go to universetoday.com/newsletter. I'm sure I don't know if I'll write one on Christmas. Maybe. We'll see. All right. Thanks, everybody. And we will see you all next year. Lots of good stuff coming your way.